Good morning, friends. Uh, Today's topic is mechanical properties of solids. The solids are also known as a rigid body. Rigid body means the one which is having a definite shape as well as a size. See, once we apply a force on object, then there is no change in its shape as well as a size. So those objects we are calling it as a rigid body. So this solid is also known as a rigid body. But all solids, they are not perfectly rigid body, because whenever force is applied on that object, then there is some internal change in its configuration. So because of that, we are not calling all the solids as a perfectly rigid body. So whenever we are applying a force on material, then there is a change in its configuration. See, for example, here the scale. So I am applying the force on this scale. Then what is happening? Then there is a change in its configuration. See, it is bending. So whenever I am removing my force, then what is happening? It is regaining its original shape. So this we are calling it as a elastic property of solid. So this elasticity or this elastic property helps in manufacturing of cars or helps in manufacturing of bridges. So like elasticity, there are other properties are there, and those properties are like the first one is we discussed elasticity, and the second one is plasticity. So the elasticity, I have told that whenever we apply force on the material, then there is a change in its configuration, but after removing the load, then it will regain its original shape. So we have, for example, steel rod is there. So whenever we are applying the force, then what happens? There is a change in its length. So whenever we are removing that load, it is regaining its original shape. So even in the rubber we are applying the force, then it will be stretches, and after removing that load, it is regaining its original shape. And here the steel is possessing more elasticity as compared to rubber, because the rubber, what will happen whenever we apply a force, it will not regain its original shape, it will loses its original property, but steel, it will regain its original shape. So the material which is regaining its original shape, so those material we are telling it as that material is having a higher elasticity. So steel is having a more elasticity than rubber. And the next comes to plasticity. The plasticity meaning is whenever we apply a force on that object, then there is a complete deformation of that material. Means it will not regain its original shape. So that we are calling it as a plasticity. See, whenever the plastic material is there, so whenever we stretches, it will elongate, and once we are removing that load, it will not regain its original shape. So the example for plasticity is wax or mud, or even we can take a peda. So whenever we apply force on peda, then what happens? Then the material will be changing its configuration. It will completely change in its configuration, or the material will be deformed completely. Even the wax is also completely deformed. It means it will not regain its original shape. So that we are calling it as a plasticity. And the next comes ductility. So in the ductility, we can make a solids into thin wires. We can make solids into thin wires. So this is ductility. And even for example, whatever the pencil we are using, so that pencil which is made up of wood, that shows a ductile in nature. And even this ductility shows one property, like before breaking, it will give some crack sound, and even it will form neck formation before breaking of the material. See, this is take this one as a pencil. So whenever I am applying the force on this material, See, I will apply shear force on that material. So material will be brecks here. So after breaking, it looks like this. So it will form a neck formation like this. So this is what? This is a ductility nature. Next comes a plasticity. Sorry. Next comes brittle material. So the example for this one is chalk. So it will not show any neck formation. So these material will suddenly break. So these are harder material as compared to ductile material. So they are more harder material as compared to ductile material. And see, there is a chalk. So whenever I am applying a force on this chalk, then what happens? Then it will suddenly break. See here, there is no neck formation like this. And the next comes malleability. So this malleability means we can form into thin sheets, so which helps in manufacturing our cars. So these are the properties of solids. And the next important concept is stress and strain. So the stress is nothing but, so whenever we are applying the force on that material, then there is a internal resistance force is developed. For example, see, I am applying a force on my finger. So this finger is suddenly it is not breaking because it has some internal resistance capacity. So whenever my applied force is greater than that internal resistance force, then only this finger will be breaks. So whatever that internal resistance force we are calling it as a stress. So this internal resistance force developed per unit area is called as stress. And the formula for stress is force divided by area, and the SI unit of force is Newton and area is meter square. And this stress is scalar quantity, so it depends only on magnitude and not on the direction. And this stress is again subdivided into three types. The one is normal stress, and second one is hydraulic stress, and third one is shear stress. So shear stress is also known as tangential stress. Right? These are all depends on how the force we are applying on that material. See, if I am applying a normal force on the material, then there is a development of normal stress. If I am applying a hydraulic force, then there is a development of hydraulic stress. And if I am applying a shear force, then there is a development of shear stress. So the first one is first we will discuss about what is normal force. So normal force is nothing but, so we have two types of normal force. One is tensile force and another one is compressive force. So there's tensile force. See, there is an object, so it has a two principal axes. One is vertical axis and another one is horizontal axis. So tensile force is nothing but two opposing forces which is acting on that object. Two opposing forces which is acting on the object. See, these are the two forces, F1 and F2. They are acting opposite, and due to what is happening, there is elongation of that material. So the material will be stretches. So there is increase in its length. So whenever I am applying the tensile force, then internally there is resistance force is developed. That resistance force we are calling it as a tensile stress. So because of this tensile force, then the tensile stress will be developed. See here, whatever the forces is acting, these forces are acting along the normal of that surface. This is acting normal on that surface or the normal of the axis. See, I can apply forces here also. So if I apply forces like this, F3 and F4, then the material will be stretches like this. There is an elongation along the vertical axis. So because of that, internally resistance force is developed. So that we are calling it as a tensile stress. And the next comes compressive force. And because of that compressive force, there is a development of compressive stress. And here in the compressive force, there is a decrease in its length. See, I am applying the force like this. So because of that, the decreases in its length. And here the forces is acting along the axis. So the forces is acting along the axis of that object. So I can apply here also. So because of that, the material will be deforming or there is a decrease in its length. So whenever this force is acting along the axis, then this is compressive force. Compressive force. Because of that compressive force, the stress internal resistance force is developed. That we are calling it as a compressive stress. So the normal stress is divided into two parts. The one is compressed tensile stress and second one is compressive stress. And the next comes, so in the tensile stress, the material will be elongation. There is an increase in its length. In the compressive stress, there is a decrease in its length. Next comes hydraulic stress. So in the hydraulic stress, so as I told, we are applying a hydraulic force. That hydraulic force is nothing but whenever the force is applying on any object, if that force is perpendicular to that surface area, then that is called as hydraulic force. So whenever we are applying a hydraulic type of a force, then there is an internal resistance force is developed, that we are calling it as a hydraulic stress. See, there is a wall here. I am applying the force. See, this force is perpendicular to this surface area. So I am applying the force here. So this is also perpendicular. So this is nothing but hydraulic force. So because of this hydraulic force, then there is a development of hydraulic stress. So now what happens? There is a decrease in its value. So the initial value of this wall will be, I am taking it as a B. So after that, what is happening? There is a decrease in its value. So this is change in its value. So this is, we are calling it as a hydraulic stress. And the next comes shear stress. The shear stress, here we are applying the shear force. Shear force is nothing but, see, this is a horizontal axis and this is a vertical axis. Shear force is nothing but two parallel force. Parallel means this is a one force and this is another force. These two forces are parallel to this axis. So horizontal axis of that object. So whenever we are applying the force like this, then there is a development of shear stress. The material breaks at the middle. So even I can apply forces like this. So this is a vertical axis. So I can apply forces like this. So this is a F1 force and this is a F2 force. These two forces are parallel to the middle axis of that object. So because of that, material will be breaks here. The material will breaks here, and here the material will be breaks like this. Here the material will break like this. So this is a shear stress, or we can also call it as a tangential stress. Similarly, another most important factor is strain. The strain is nothing but whenever we are applying a force on that object, then there is a change in its configuration. The configuration might be in terms of length, in terms of area, or in terms of value. So those things I will write in this board. So I hope I have cleared a types of stresses. So normal stress, that normal stress is divided into two parts. One is tensile as well as a compressive, and the next one is hydraulic stress, and the third one is shear stress as well as a tangential stress. The next is the strain. So force is applied on the object, then there is a change in its configuration. Change in its configuration. So the configuration might be in terms of length, area as well as a value. So this is a change in its configuration. So the formula for strain is change in length divided by original length. So again, this strain is has three types. The one is you can call it as a normal strain, and second one is shear strain, and third one is volumetric strain. So the normal strain is nothing but we have already discussed. We are applying two types of forces, normal forces. One is tensile as well as a compressive. In the tensile, there is an increase in its length. In compressive, there is a decrease in its length. So that strain formula is nothing but changing a length divided by original length. Divided by original length. See that now this we are calling it as a normal strain. So if I am applying tensile force, there is development of tensile stress. Then because of that, change in its length. So change in its length means there is increase in its length. So that increase in a length divided by original length, we can call it as a normal strain. So whenever we are applying a compressive kind of a force, then there is a development of compressive stress. Because of that, there is a decrease in a length. So that decrease in a length divided by original length, that again we are calling it as a normal strain. So here there is a object is there which is fixed at one end. So I am applying a force on this. So this is initial length L. So because of that force, what is happening? There will be change in its length. So the length is increasing. So this increase in a length, I am taking it as a delta L. So the now formula becomes delta L divided by L. Strain is nothing but delta L divided by L. So here this force I am calling it as a tensile force. So because of that, the tensile force, because of that increase in the length, because of that tensile stress is developing. And suppose rigid object is there, I am applying a force like this. So this is a increase in its, so this is a length, original length. Now what happens? The material will be deformed. So this is delta A. So this is decrease in the length. So this is nothing but compressive kind of a force we are applying. So compressive stress is developed. So this is here also the formula is change in length divided by original length. Here length is decreasing and here length is increasing. That is the only difference. And the next comes shear strain. The shear strain here there is a small change in its configuration. So little change in its configuration on that material, small change in configuration. So see, shear strain. So there is a rigid object is here. So now I am applying a force like this. So because of that force, the material is tilting. So see, instead of three dimension, I will draw 2 dimension. So now I am applying a force like this. So because of that, there is some bending of that object will be occurs. So it will be bent like this. So this is a theta, and this is change in its length x, and this is the original length here. So now this one is a shear strain. See, this force is parallel to this principal axis. So this is the object. So the object is having a principal axis. This is vertical, and this is horizontal. So this force is parallel to this principal axis. So this is a shear strain. So the formula for shear strain, so x divided by L. And the next last one is volumetric strain. So the third type is volumetric strain. So here to change in terms of volume, we need to apply hydraulic stress. So there is a ball, so we are applying the hydraulic force. So because of that, hydraulic stress will be developed. So this is a original value. So whenever we are applying hydraulic kind of a force, then there is a decrease in its length. So length will be decreasing. Sorry, it's not a length. This is a volume. Why it is decreasing? So this is change in its value, that is delta V. So that volumetric strain is calculated by the formula volumetric strain. Volumetric strain is equal to what I will write, delta V by V. See, we have discussed about the stress. The stress is having three types. One is normal stress, and the second one is shear stress, and the third one is hydraulic stress. So similarly, we have three kinds of a strain. One is normal strain, and the next one is hydraulic strain, and the third one is volumetric strain. So the next we will discuss about next topic. We will discuss about modulus of elasticity. Pause ಮಾಡಿರಿ.
ಇಲ್ಲ.